In the last section, we saw some evidence that a function call to pbk_df2 is not actually single-threaded. In this section, we're going to expand on this example a little bit and figure out why we are seeing this behavior. First, let's look at a diagram of what's actually going on with a pbk_df2 function behind the scenes. So remember, we dove into the source code of this function a little bit ago. And as we saw, the pbk_df2 function has both the JavaScript implementation, but it actually delegated all the work to be done to the C++ side. So that's where the actual hashing process took place. We also saw very briefly in that C++ file that there seemed to be some references to the libuv library, which, as you'll recall, gives Node some better access to the underlying operating system. The libuv module has another responsibility that is relevant for some very particular functions in the standard library. So for some, that's the keyword here, for some standard library function calls, the Node C++ side and libuv decide to do expensive calculations outside of the event loop entirely. Instead, they make use of something called a thread pool. The thread pool is a series of 4 threads that can be used for running computationally intensive tasks, such as the pbk_df2 function. By default, libuv creates 4 threads in this thread pool. So that means that in addition to the thread used for the event loop, there are 4 other threads that can be used to offload expensive calculations that need to occur inside of our application. Many of the functions included in this Node standard library will automatically make use of this thread pool. And as you might imagine, the pbk_df2 function is one of them. Now, the presence of this thread pool is very significant. Obviously, from the standpoint of people always saying, oh yeah, Node is single-threaded, Node is single-threaded. Well, clearly, it's not truly single-threaded because there are other threads that Node uses for doing some computationally intensive tasks. You see this thread pool here because if our event loop was responsible for doing this computationally intensive task, that means that our Node application could do absolutely nothing else while we were running the pbk_df2 function. Remember, our CPU runs all the instructions inside of a thread one by one. So if our thread had some line of instruction inside of it that said, run this code that takes 1 second to run, then that's pretty much it. We have to wait 1 second for that code to run. So by using this thread pool right here, we don't have to wait that 1 second, and we can do other things inside of our event loop while that calculation is occurring. Okay, so now that we have seen this thread pool right here, let's take a quick pause. We're going to come back to the next section and we're going to modify our file just a little bit, and it's going to allow us to actually detect the presence of these 4 threads inside the thread pool. So quick break, and I'll see you in just a minute.